And now we are moving a little bit different in topologies. We will do some definitions, and we will also solve so many examples and exercise related to definitions. Now the most important concept over here is just like as we have described before in discrete topology, and here we are describing discrete topology. So what is discrete topology? Okay, the discrete topology can be defined as the power set P of X of a non-empty set of a non-empty set X is called the discrete topology. Discrete topology. So the power sets of X. If X is a non-empty, then all the subsets of X, all the possible subsets of X, which is also called power set. Okay, so all the possible subsets of X contained in a set is called power set, and the topology on power set of X is called discrete topology. As we have described before, topology on phi and X only is indiscrete topology, and the topology on power sets of X is called discrete topology. And now there are two more definitions, and these definitions are related to just like as it is cursor, and finite topology. And finite. Yes. In this case, let tau1 and tau2 are two topologies. Tau1 and tau2 are two topologies. Okay, if tau1 and tau2 are two topologies, and there is one condition, and that condition is just like if tau1 is contained in tau2, and let tau1 is contained in tau2, okay, and that is each member of tau1 is also the member of tau2, then it means that tau1 here, tau1 is said to be cursor or weaker. Here if tau1 is contained in tau2, then it means that tau1 is cursor, it may be read just like as cursor or weaker topology. weaker, and the second is tar2, which is stronger topology, is also called is thinner or stronger. Stronger topology. Okay, hope you have understand these two definitions. And first of all, what is discrete topology and what is coarser and thinner topology, and now we do some example related to coarser and thinner and discrete topology. Okay, the first example I am doing over here is that it is just like as it is x is equal to, just like given that it is a, b and c, these are three elements. Okay, and the discrete topology, find the discrete topology. We want to find the discrete topology, which is tau, and it of course is the power set of x, and the power set of x means that it will be empty set a and b, it will be c, of course it will be ab, and AC, AB, AC, and BC. Yes, of course at the end you will write x. These are the, so this is the power set of x, and of course this is a topology, and this topology is actually called the discrete topology. Okay, now we'll take another example, and in this example, just like you will write yes, it is given that x is equal to 1, 2 and 3. Okay, so here we want to construct both indiscrete and discrete topology. When we talk about the indiscrete topology, then of course it will be just like as tau1, it will contain only the empty set phi and the set 1, 2 and 3. This is tau1 is indiscrete topology, and tau2 will be just like as it is tau2, which is discrete topology, empty set, and then 1, 2, 3, 1 and 2, 1 and 3, and 2 and 3, then you will write x. Okay, so here tau2 is actually the discrete topology. Hope you have understand about discrete and indiscrete topology, coarser and weaker topology. I will meet you in the next lecture.